Today's lesson is on modeling data using logarithmic functions. The number of members that belong to a math club versus the number of months that has been established is given in the table below. In the first month, there's 10 people. In the third month, there's 20. After 6 months, there's 37. After a full year or 12 months, there's 48. After 18 months, there's 54. And after 25 months, there's 58. Construct a scatter plot. You have to, when you're constructing the scatter plot, you have to think about what goes where. And time in months goes on the horizontal axis, and members go on the vertical axis. For these grids, there's 20 grid squares going in each direction. So for the month, we probably have to make every month worth 2. So that's 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Vertically, we get to a total of 58. So we must go up to at least 58. Let's go up to 60. So that means that every grid square is worth 3, and 2 grid squares is worth 6. 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Okay? Okay. Now, we're going to plot the points. After 1 month, there is 10 people. That's right here. After 3 months, there's 20. That's right here. After 6 months, there's 37. That's right here. After 12 months, there's 48. That's right there. After 18 months, there's 54. That's right there. Just going to make these a little bit bigger. And after 25 months, there is 58. So we can see that the growth starts off really sharply and continues from there. So it would be reasonable to expect that at month 0, there's no people. So we got something that looks like this. And just like when we talked about logarithmic growth in the past, logarithmic growth is growth, but it really tapers off. So find a logarithmic model for the data. So we're gonna have to type these numbers into Desmos, and when we do that, after we do that, we're gonna come up with the equation y1 approximately equal to a plus b ln of x1, and that will give us a logarithmic equation that will model the data. All right, so Desmos tells us the equation of the logarithmic model is y equals 2 decimal places, 7.57 plus 15.81 times the ln of x. Now, if we want to use contextual variables, which is what we prefer, maybe m for members, m equals 7.57 plus 15.81 times the ln of t, where t represents the time. And that's a logarithmic model. Okay? And it wouldn't hurt to put the variables here. So this would be t for time and m for months going vertically. So m is equal to 7.57 plus 15.81 times the ln of t. Now, the first question asks, how many members will there be after 3 years? Now, judging from the table, the values that we have, we probably would expect maybe a little bit over 60, but not much over 60. So, to answer this question, we're going to go into Desmos and type in what?
X equals 36.
X equals 36, and we're going to see where these intersect. Okay, not a bad idea to kind of show our work here. Here's our graph. Here's this. Here's this. X equals 36, and it's at 36, 64.229. So how many members are there after 3 years? Well, I would say there are 64 members. And just remember, members are people, and people are discrete, which means that we don't need 2 decimal places when we're talking about people. It's either we're rounding up or rounding down. And because this is growing, I might feel that with the rounding the way it goes, I'd be rounding down until I had to round up, like even until you got to 65. So there's 64 members after 3 years, okay? Now, we got one extra part to this question. Kyla says she's going to join the club when it reaches 100 members. When will Kyla join the math club? So it's the same old thing, except now what we're going to do is we want to know when is it going to be at 100 for a y value. We want to know what the x value is going to be. And we're going to go back to Desmos, and we're going to type in y equals 100 to help us answer that question. We see that Kyla is a joker because it's 305.845. Do I remember that right? 305?
345.805.
Sorry, I got the 0 and the 4 mixed up. 345.805. Now, the 345 is the number of months. The number of months. So she's not, and if she's not joining until there's 100 members, if she's not joining until there's at least 100 members, it might be a good idea to round this up. So we probably say 346 months. Now, when we say 346 months, that doesn't mean a lot, because what's 346 months? Well, we know that there's 12 months in a year. So if you divide 346 by 12, 346 divided by 12, you see that it's 28.83 years from now. So Kyla is not in a rush to join the math club. She's going to join in 28.83 years. And we talked about limitations of models when we talked about the exponential models. You could definitely talk about the same thing here too. Although we see the growth is almost non-existent after a certain point, I mean, no matter what, there's going to be a point where no one else is probably going to join the club, because everybody that's wanted to join the club has probably already joined the club. So the domain or the range are things that we have to think about when we think about, like, does it make sense? For example, does it make sense that the range would go from 0 to infinity here? And the answer is probably not. Like, I guess technically yes, but, like, and there's no real, like, if the answer is no, or if we say the answer is 0 to infinity, we can say that there's a limitation because we expect that at some point everybody that's joined the math club is already going to have joined the math club. So, okay. All right. Try some practice questions on pages 494 to 499.